Hey everybody, welcome to Data Umbrella's webinar. I'm going to do a brief introduction about Data Umbrella, then Pablo will do his talk. And during the talk, you can put your questions in the chat or the Q&A, and we will get them answered when is a good time to break for it. This is being recorded and will be placed on our YouTube within 24 hours usually. Data Umbrella is a community for underrepresented persons in data science. We are a nonprofit organization. This is our team. My name is Reshama Sheikh. Beryl is out of Kenya. Christina is out of New York. I'm out of New York as well. And Sangam is out of India. And these are the people that make it happen behind the scenes. And we have a new community contributor, Leslie, as well. And we hope she'll join us when her schedule permits. We have a code of conduct, and we thank you for helping to make this a welcoming, friendly community for all. There are various ways to support Data Umbrella. The first and foremost is to follow our code of conduct. And if you could share our events with other people in your network, that would be wonderful. We also have a bunch of open source projects in terms of our website, doing timestamps for these events, open source sprints. Check it out on our website. If you'd like to donate to us, give us a contact us at info@dataumbrella.org. We do have a new fiscal sponsor. You can also subscribe to our YouTube channel. We have a very rich library of events related to data science, Python, RStats, open source, and a lot of peripheral technologies. Definitely check them out. Our YouTube channel is doing very well in terms of views and subscribers. One of the playlists we have is career advice. Others are data visualization, contributing to open source. We have a series on PyMC, scikit-learn, and NumPy. We also have a monthly newsletter at dataumbrella.substack.com. We send it only out once a month. So if you're interested in community updates, subscribe to our newsletter. These are our platforms with the most activity. Meetup is the place for upcoming events. YouTube is the place to go to for recent event videos. This platform that we are using is called Big Marker, and at the top right, you'll see two letters, CC, for closed captioning. So if you'd like live transcripts at the bottom of this screen, just hit CC. We also have an online suggestion box. I'll share the link in the chat, but if you have suggestions for future event topics, if you have any feedback on this event, if you would like to speak at a Data Umbrella event, let us know. Our next event is on November 19th, Understanding Polars Expressions When You Are Used to Pandas, and this will be with Marco Gorelli, who is a core contributor to Pandas and Polars as well, and that should be a really good talk. Today's talk is Ragged Edge Box, a personal AI-powered document search system. Our speaker is Dr. Pablo Duboue. He is an independent language technologist, and his work focuses on applied language technology and natural language generation. He has a licenciatura in computation degree from Córdoba University in Argentina, and MS Master of Philosophy and PhD degrees in computer science from Columbia University in New York City. He is passionate about improving society through language technology and splits his time between teaching, doing research, and contributing to free software projects. He has taught at Córdoba University, Columbia University, Siglo 21 University, and has worked for IBM TJ Watson Research as a research staff member. You can find Pablo on LinkedIn, and here are the links to his other social media platforms. And with that, I am handing over the screen to Pablo.
All right. Hello, everybody. Let me present the slides. Okay, so the slides are available for download on the Hangout, in the handouts for the presentation, and they will also be available for download on the website for the project. If you want to check out the project, you can go to the URL there, and Reshama posted also on the chat the link. There is a VM available for download. I'm testing a new one that should be able to put out after the presentation, and that one has like about 8 bugs fixed that I was working on for this talk. But in the meantime, let me show you some screenshots about what you can expect from this. The virtual machine is about 2.8 gigabytes. When you download it, you have to install VirtualBox. And once you open up, you will have a browser running locally inside the virtual machine. And then you can open it with your web browser on your machine, and you will see this interface. This interface, you can do searches, you can upload documents, and you can browse the documents that you have stored within the search system. So in here, I am uploading a book I wrote a few years ago on feature engineering. So this is a whole book in one PDF file. And we're going to index it using embeddings, which I will discuss shortly. The whole upload takes about 4 minutes. So that's extracting the text from the PDF, splitting it into sections called chunks, computing embeddings for each chunk, and then storing the vectors for each chunk into an embedding database. After that, then we can run questions over those embeddings. For example, we can ask when it is advisable to use feature normalization, which is something that you will expect can be answered from a book on feature engineering. So here, the system then does the search, and the search happens quite fast. And after that, it takes a piece of the document that is more relevant to the question and executes a local large language model to extract an answer. And the answer here is shown in green, and it's an okay answer. I mean, it doesn't answer the question directly, but it has enough information relevant to the question to be useful. And that takes about half a minute for doing the extraction, while the search itself takes about 3 seconds. So that's pretty much what the project is about. You can also just execute the search, and you will get different passages, and you can press the green button answer from here to execute the LLM just on the specific chunk. If you feel that you don't want to execute the half a minute for something that may not be that relevant. So that gives you an idea of what to expect and what the project is about from the perspective of a user and the type of functionality it provides. Now, for this type of project and for this type of talk, I would expect a fairly heterogeneous audience. As such, this talk has a little bit for everybody, and I've been trying to distinguish which different parts of the talk go for different type of attendees. Yes, I will expect some people are scientists, yes, and their interest in this project lies in being able to outreach, to share the research to the world without having to host expensive servers. In that way, they can take some of ideas from the research, say they are doing specific things with LLMs, or they are doing specific things on information retrieval, and put them within this Ragged Edge box project and make their own version of the virtual machine that showcases the research and share it to the world. I will also expect that some of the people watching this, attending this talk, are potential users. And these are people who value their privacy and also don't want to pay server fees. So they can use this type of search systems locally and cheaply. Then you have people who are interested in the technology. for example, as potential reusers. They are not interested on this particular technology I put inside, but they want the virtual machine and they want to use it with a different stack. Instead of using, for example, the PHP, they want to replace everything with, say, Python. Variant of these users interested in technology are people interested in a commercial use, what I consider the potential independent software vendors. So these are people who like to build and sell solutions on top of Ragged Edge Box. And well, these people then will, of course, know PHP, which is actually a very popular language among independent software vendors. And finally, we have other people interested in the technology, but now as potential contributors because they are interested in artificial intelligence and they value free software, free and open source libre software. Given that, this talk has these different sections. The sections are fairly small, so don't be afraid. It's not a very long talk. And the different talks will be of interest to this different type of attendee personas. We already seen a very short canned demo of the tool. I prefer a canned demo than a live demo because it takes, half a minute to run to do the extraction. But if we have time at the end, I can do a live demo. So let's start with some artificial intelligence concepts that are relevant to value what Ragged Edge Box is. The first one, of course, is what is Retrieval Augmented Generation. I mean, it's in the name of the project. The intention in Retrieval Augmented Generation is to combine LLMs, which we will define next, with existing information. So it's a three-step process. We retrieve information using search engines. And there is a variety of search engines out there. The ones that are popular for this include embedding-based search engines, which we'll discuss shortly. And I think we have a question. No. Okay. So you take the results from that search engine and you give it to the LLM as input in the prompt. And then you ask the LLM to do things with that information you have provided. For example, to answer a question. So the advantage of Retrieval Augmented Generation is that you are controlling the information the LLM is using to do the task, and therefore you are reducing the potential for errors that can be produced by the LLM. But what are LLMs? Yes. So think of, well, it's a large language model. And what is a language model? The most common language model we have access to these days is the autocomplete in our cell phones. Yes, and in a way, the cell phone knows things. Yes, it has an understanding of us through the exposure to the type of text we write. If I start writing, I really want to, most probably will say something more like eat empanadas than to learn about LLMs. Yes, and in the similar way, an LLM is a language model, but it has seen tons and tons of text. It has seen, a whole web crawl. And even more so, some of those texts contain exams and their answers. So then the system can actually fill in the blank and do things based on that go beyond just auto-completing. Moreover, most recent LLMs are also trained directly on instructions. So you can tell the LLM precisely what to do, and it will use this understanding of human language to follow those instructions. The other piece of the RAG puzzle is doing information retrieval using this concept of embeddings. And an embedding is a way to encode information by projecting it into a fixed space. Yes. In the case of RAG and semantic search, the input is a text span, and the output is a fixed vector of floating point numbers, for example, 384 numbers. And the hope is that the text conveying similar meaning will be represented as vectors that are close to each other in Euclidean space. And of course, embeddings have many questions and issues. How do you generate these? Yes, a popular technique these days uses Siamese neural networks, in which you train two identical networks to produce these embeddings by doing Euclidean distance between the obtained embeddings and training them saying, well, these two sentences are similar, these two sentences are not similar. And that way you actually get a whole network that can produce representations that are useful for this type of task. While the embeddings have been trained based on this information, we still don't really know very precisely what type of semantic information is being captured. The other issue is how big is the text span to make sense to compare the generated vectors? Yes, do you want to index at the paragraph level, at the page level, at the section level, at the chapter level? Because as you start adding more text, then the semantic focus starts diminishing. And finally, something that is quite important for a system like RagEdgeBox is how do you compare embeddings coming from two texts where one text is short, very short, like a question, and the other is long, like a multi-paragraph piece of text. Things are called asymmetric embeddings, and the system being used currently in RagEdgeBox handles that. If you have any questions, feel free to post them in the chat. As I said, this is not a very long talk, so I'll be happy to field the questions as they come in. Now, let's take a look into retrieval augmented generation concepts that are relevant to RagEdgeBox. The first one is what we are doing in the particular RAG for RagEdgeBox is answer extraction. Yes. And answer extraction is something for which the LLMs are actually quite good at. So in answer extraction, you give a text, like the example text here that talks about a number of items, but particularly about how 42 is featured in a science fiction book. And then we ask the LLM to extract the answer to the question why people are obsessed with the number 42 from that piece of text. And then the LLM will give us an answer, but the answer is very confined to the information that appears in the small text blurb. On the other hand, we can ask an LLM, commercial large LLM like GPT-4, to answer that question directly from the implicit knowledge that it has after being trained on so many documents that have seen from the web. Yeah, so we ask exactly the same question, then we will get an answer that goes back to the same science fiction work, and then has a lot of additional information. This is because this information comes just from the weight. You can think of in a way that the LLM is dreaming this, is hallucinating this information. And this can be very risky. It can, given the nature of generating one token after another, in some moment the LLM may get off track, stop forgetting that it's answering that question, and then start adding additional information that, you know, kind of makes sense from the previous, but is already no longer relevant to the original question. Or you can just start inventing things that are not real. For example, I mean, something that was quite common early on was to start quoting scientific articles that didn't exist, but sound plausible in terms of the names of the authors and the titles and the venues. You can imagine that if you're using a system to do anything useful, you don't want these hallucinations, particularly the ones who are not true. That can be very nefarious. So RAG is a way to limit this type of behavior. Now, people are very happy with RAG up to a point, because while the LLMs work well for answer extraction, and we have this generative AI revolution, or generative AI evolution, as people are calling it now, information retrieval, has been around since the 1950s, and it's one of, in a way, the reasons why we wanted to have computers for. And generative AI has improved a lot of things, but it really haven't improved IR that much. And RAG really hinges on having great IR results. In reality, if you have a small prompt size, you cannot put a lot of information inside the prompt. Yeah. So if the information to answer the question is not retrieved, there is not so much that the LLM will be able to do. Yes. And another problem is many LLMs will not be happy to admit defeat, and they will still hallucinate an answer. Llama 2, for example, was very known for that. Getting them to say, I don't know, given the information you gave me, I cannot answer this question, is actually not easy. And something I like to say is that this is the generative AI revolution, not the IR revolution. But, well, these are things to keep in mind regarding the problem with IR in RAG systems. So currently we have IR systems using keyword search, using complex search queries, keywords plus operators, and then these embeddings that I mentioned earlier on. The best performance uses a combination of these approaches. And in particular, the complex search queries was an approach that we used quite a bit when I was at IBM doing the Jeopardy system. Yes, it's the query generation component of a question answering system. And somehow it seems that the field has completely forgotten about that technology, but it's quite important for success. Just keyword search is a little too little. If you can add a more complex search queries that you can derive from the natural language of the question, you get a lot of mileage. Finally, the information we are providing to the LLM in the RAG system is usually a segment of the relevant document. And that segment is called a chunk of the document. Why we use chunks is because, in general, the LLMs have a maximum size of the prompt. Yeah. And local LLMs, the ones you can run in your own computer, that range between 400 to 1,500 words, unless your laptop has 100 gig of RAM. That will be most probably what you can process. Commercial LLMs that you can use through APIs can process full books. Whether processing the full book is good for RAG or not, so far it seems it's not. Like, you can give the whole book, but it will not be able to answer questions as well as if you find a particular chunk on the book or chunks that are relevant. But these are things to keep in mind. If you are using chunks, then the issue is how big are these chunks? Yes, if you it has to be long enough to have enough information to answer questions, but it has to be small enough to fit into the LLM input and be semantically coherent to produce viable embeddings. And finally, some questions cannot be answered from only one part of a document or for one document. These are called multi-hop questions. So you need to provide multiple chunks to the LLM at once. That might exhaust the input and may also confuse the LLM if you don't really structure the prompt to clearly indicate that these things come from different documents or different parts of the same document. But, well, these are the current issues that need to be addressed to respect to chunks. And finally, well, I mentioned this term a few times, the prompt. Yes, this is the way we structure the input to the LLM. And different LLMs need different prompts. And sometimes they're very, very sensitive to tiny, tiny changes in the prompt, like adding an extra return, carriage return at the end of the prompt sometimes works better for some LLMs than others, things like that. These things Oh, there's a QA tab. So Christy Johnson asked what LLM model we use. I'm using the stable LLM. I'll describe it in the next section. So in the case of the current system, this is an example of a prompt for doing RAG. I think this is the LangChain prompt. This is not the prompt we're using. We're using a simpler and smaller prompt. So, but this is how a prompt for RAG looks like. Use the following pieces of context to answer the question at the end. If you don't know the answer, just say you don't know. Don't try to make up an answer. Then here in between braces, context that will be replaced by the chunk. Question, then it comes the user question, and then answer that leaves the LLM to continue the document with the answer. So now let's talk a little bit about the RAG Edge Box. So RAG Edge Box is a RAG system implemented as edge computing. Yes, the idea is that there is no backend, nothing runs in the cloud. It's a self-contained virtual machine at 3.0 gigabytes. The next version that I'm releasing today will be 2.7 gigabytes. So I managed to shave off 2.8 gigabytes. I managed to shave off 2.7 gigabytes, actually. I managed to shave off 300 megs by switching the kernel to a cloud version of the Debian kernel. So, but of those 2.7 gigabytes, you have an embedding model, which is a sentence distill Roberta model that is 326 megabytes, and a local LLM that is a Blink stable LM 3 billion quantized to 4 bits, which is 1.71 gigabytes. A standalone search engine that has keywords and embeddings, that is SQLite version 3 with the VSS and FTS extensions, and a web portal to upload the documents, index them, and query them, custom made in PHP. What I want to point out here is that if you add the size of the local LLM plus the size of the embedding models, you get 2 gigabytes. Yes, and the whole thing is, well, now it's 2.7 gigabytes. That includes the kernel and all the runtimes and everything. While PyTorch itself is a 1 gigabyte download. Yes, so the thing I like about this project is how using PHP, we can make such a succinct deliverable. And I'll talk more about that in a second. So what are the goals of the project? What do you get instead of just using RAG against OpenAI API? Well, searching in a document collection should not involve giving access to the documents to a third party. If you have private legal documents, medical documents, those type of things should not leave your laptop. And the name cloud is really a misnomer. It's just someone else's computer. Then there are issues of technical sovereignty. Yes, many people attending this talk are in different countries. I'm, for example, in Canada, not in US. And so solutions relying on APIs hosted in other countries are not particularly sovereign. And also, many solutions involve using extremely expensive hardware. I'm talking about $50,000 GPUs. That's also not particularly sovereign for countries that people don't have the budget to have such level of expensive hardware. And then something that, even that I've been 25 years in the field, I'm a little tired of this sort of planned obsolescence. Yes. So we have a question in the chat about what do I mean by someone else's computer. What I mean is when you say I'm running this on the cloud, sounds like it's you know, the Olympus, some magical place. But it's just Google computers or Amazon computers, yes. And you are transferring. I do find the cloud as a marketing term for people to forget that this is not your computer, it's someone else's computer, and by that they have access to your data. Yes. If you have, well, so in the chat they are saying like a server. You can have your own servers within your own premises. Yes, that wouldn't make someone else's computers. Yeah. It's more about the fact that the cloud involves a cloud vendor. If you have your own cloud in your own premises, then it's a different matter. Okay, so regarding the planned obsolescence, yes, I'm getting very tired of tools that no longer work after a few months. Yeah, I don't know if you have experience, but system Python upgrades break all your virtual environments. So it feels like things that were working 8 months ago, all of a sudden no longer work. That makes using software and relying on it for things that are not just research and development very annoying. And if you use cloud solutions, then somebody else has to deal with that, and they have to maintain all versions of the software or upgrade them continuously. I mean, it's their problem. But for tools that we want to rely in our own machines, this idea of using a virtual machine has a life cycle independent of the operating system life cycle. I find it very appealing. You can download a tool, and the tool will remain useful for years. Moreover, the technical decisions behind the RagEdge involve using long-term versions of tools, and they're also all packed on version, and the versions will be available for a long while. Docker, Debian Stable, Composer, etc. Composer is the PHP packaging system. So now I'm going to get a little more technical and discuss a little bit about the architecture of the system, and I will share my screen, and we'll go through some of the code on GitHub. So at its core, RagEdge is those 3 files in, I mean, the web portal is these 3 files. Most of the work on RagEdge were on the Docker and make image scripts that I will also cover shortly. So, and these 3 files rely heavily on a Composer package, a PHP package, for doing semantic search, which we'll also discuss in a bit. So let me share my screen. Mm-hmm. Okay, so this is the RagEdge project. Mm-hmm. And the PHP code here is inside. So I'm using really vanilla PHP here, which means that every page you have is a PHP file. And if you want to change something, you use the system and you want to add some additional functionality, you don't really need to go very deep about where is that functionality. You look at the URL and you see where it is. So let's say you are uploading a file. Yes. And so this is the code that upload the file. And here it executes a program on the box to determine the type of file, and then depending on the type of file, it executes some other programs to obtain text from them. So if you want to process other files, all you have to do is to add here for another MIME type, what type of tool you want to execute. After the text has been extracted, then the system calls the indexer over that text. In this line, yeah, calls here the ingester with the actual file. Yeah, so that's you have an index page that has these different tabs. The 3 tabs I saw at the beginning of upload, search, and a tab I didn't show that you can browse the files. It's a mixture of code and interface, which by now, as a whole in the field, we know is a bad idea for large projects, but for a small project like this, makes things easier. There is a number of issues available, still not fixed in the system. Some of them are good for newcomers if you want to contribute to the project. For this talk, I actually close all these bugs in the new version that is coming, so you'll have a nicer version. And now, most of the work, all the meaningful work in terms of semantic search is done in the PHP semantic search classes. So let's dive on that. Yeah. So this is the PHP semantic classes. They use Roberta as the embedder and the SQLite vector search, which is an extension. And it takes a JSON-L format of documents. And then it does a document search on that. For example, we can index, part of the tool has a set of Stack Overflow documents, and you can index and you will get this type of results. It will tell you the URL, it will tell you the title, etc. Yeah, and you can try different things. This is keyword search, this is vector search, this is re-ranked. We have a system where you expand the question with a generated answer using LLMs, call it the hydration technique. You have and then one of the nice things is that the chunker, it supports splitting documents into chunks, but also keeping the offsets on the original documents where the chunks happen. But let me show you. So here, what I wanted to show you was the for the embedder. Yeah, so these are the classes provided by the system. So you have a number of classes here. For Ragged Box, the most important class here is the embedder. Yes, it takes a text and it gives you the array. So it produces this transformation of a piece of text into this vector of floating point numbers. And there is a number of embedders available. The one we are using is the the sentence transformer embedder. And this one uses the sentence Roberta. Particular importance for us is that the size of this embedder is 778. 768, that's the output size of the embedder. And the input size is 512 tokens. Then I also wanted to show you the index. This is the index interface. You give a question, I give you back as an array of search results. You can add documents. You can fetch a document from the index. You can see what tokenizer is being used, the maximum document size that is important for chunking. And finally, the last item to show you here is a tokenizer. So if you change any of these classes, then you can, if you provide implementation for these interfaces, you can make the system work with a completely different tokenizer, a completely different indexer, etc. And now we go back to the slides. So just want to show you that PHP, well, is very unpopular. Not that different from other things you may have seen, and can be quite readable. So what is the enabling technologies behind RagEdgeBox? By far, the most important technological piece for us is the ONNX, the Open Neural Network Exchange. You can learn more about ONNX in ONNX.ai. It's specify the neural network graph in a vendor-independent way. So if you look at a neural net, it's a graph of computational nodes that process data and take inputs and outputs, yes. So when you train a neural network using any framework, PyTorch, TensorFlow, JAX, any of the famous frameworks, you can then export it to the ONNX framework format and execute it using a different framework, yes. So you can execute it without large dependencies. The networks we are using in this project were all trained using most probably Torch, with all their giant dependencies it needs, and the CUDA dependencies in the GPU, etc. But now we just have the bare model exported in this very lean graph sharing format, extension ONNX precisely. And then we can use the open source ONNX runtime created and maintained by Microsoft. Yes, and this ONNX runtime is accessed through the foreign function interface from PHP. It directly loads the DLL and executes it. And it has already been packaged for PHP by Andrew Kane. Just a notice, if you use the ONNX runtime by Microsoft, you have to disable certain things. Otherwise, every time you run it, it actually calls back to Microsoft. It's quite insidious in terms of privacy. The other big piece of technology for making this work is to be able to run a small enough LLM that can fit into a computer and to run it locally, efficiently. For that, there is this excellent project called LLAMA.CPP. It's a transformer implementation in C++ with high performance execution on CPU. One of the executables of the project is the Llama server, which allows local API calls. And it supports a LLM framework, a format called GGUF that allow for mixed execution using GPUs too. I mean, that's not supported on the virtual machine because the virtual machine doesn't have access to any GPU. But one of the changes I recently improved into the system is to be able to specify the endpoint. So you could run the local LLM in your actual computer and use it from the virtual machine. All right, so when I discuss these things, people are very curious about why I use PHP for this. It's not like PHP is my favorite language. I prefer Scala, Haskell, even C++, like languages which are more clearly typed, yes. But the thing is that PHP has very, very large installed code bases out there. Wikimedia, WordPress, Nextcloud is used in nearly 80% of all websites, and it has a lot of brain power available worldwide. And for this particular project, a PHP install is simpler and smaller than a Python, Java, or equivalent. The other thing I like about PHP is that the scripts are designed to, every time you do a request, they are parsed, compiled, executed, and die, a cleanup. And that's, in a way, a very functional paradigm. All the side effects go to a database or disk files. And even though the death of PHP has been heralded for decades by now, it's still the 11th most popular programming language last year. Another part that is particularly important for that umbrella is that I do find the open source community within PHP much self-sustainable, in the sense of PHP is the only language among the languages I program in which I have been paid to do open source, and where people in general, if they want you to do some improvement on a project, they ask you for a quote, which is a welcome change from other communities like Python, where people somehow seem to expect that you are working for fame, and that fame will translate in a good paying corporate job. But it's not self-sustainable as such. And I know this is a topic of continuous conversation, particularly for that umbrella. So in the case of these PHP semantic search classes, they were actually paid work as a subcontract with Evoludata, a Quebec company specialized in PHP solutions. You have the founder of Evoludata giving a talk here a few months ago, Marc Laporte. This was funded through an AI innovation grant from the Quebec government. So from all that work, now we can all benefit from that effort. This is available for download directly on packages. I was just showing you the code a little bit. The keyword index implements the Okapi VM25 on top of SQLite 3 text search. The vector index uses the extension VSS, that is a packaging of the FAISS vector search from Facebook research. And as I was mentioning, also support hide and local LLM embeddings. And this is the way you can ingest a JSON-L containing multiple documents into a database using vector search. And you have actually a number of packages to make this happen. You have a Roberta package in PHP. You have a tokenizer for Roberta. And then the sentence transformers. We have a question on the chat about how the models updates are deployed. No, there are no model updates at the moment. There is a bug about enhancement if people want to upgrade the virtual machine with deltas, but that's not performed right now. The virtual machine is supposed to run without internet connection, so it wouldn't be downloading updates on its own. The model, so the intention is the virtual machine to be versioned, not really the models. Yes, and from the user's perspective, they just want the system to work, not so much care about which part of the system are changing. But yes, the intention of being able to upgrade things is in the roadmap. One of the problems is that if you change certain parts, particularly the embedders, you will have to index all your collection. You will have to drop everything you have, and that will be a fairly expensive operation. So I have another question here in the chat about the vector DB I'm using. Yes, I'm using a vector DB. The vector DB I'm using is SQLite. I'm using an extension for SQLite, call it VSS, which is actually currently discontinued and a new version is being developed, but so far I'm happily using it. It works, which is a packaging of FAISS, FAISS, within SQLite. The main drawback it has is that it doesn't handle more than 1 gigabyte of indices. Yeah, but it is a bona fide vector database. It works fast and efficiently, as fast and efficient as FAISS does. So this is how the embeddings work. You use the sentence Roberta class from sentence transformers. You create an instance of it, and then you say, I want to get embedding for that text. Or alternatively, you can use the sentence transformer embedder that comes from the semantic classes, and you will also get the embedding itself. So one of the part of the contract that was a substantive amount of work is that these classes give you the same output as if you were executing the model under in Python from Hugging Face. So I have to study the code from Hugging Face in a lot of detail and make sure that absolutely every part of the whole thing will produce the same output. Some parts on the sentence transformers, for example, couldn't be executed fully on ONNX. So I have some mean pool layers and some specific manipulations that they were doing outside the ONNX in plain PHP. So in that sense, this is, to me, is one of the main contributions of these PHP semantic search classes, that you will get the same result and they are cross-compatible. All right, so how to extend this? If you want to do a new information retrieval, you can subclass the index PHP from the PHP semantic search. I think we just look at it already. If you want to add a new LLM, so if you're going to run the system from a different LLM, you put it in the download folder of the Rugged box and change the launch llama shell script to use it. Yes, the current, I'll show you in a second what that means. If you want to do better document handling, you can change the upload PHP. I think I discussed that. And I'm going to talk a little bit about the VM system, and then I'm going to share my screen and we will go through the code on that. So the most interesting part of this project is this Docker file and this make image that takes, compiles all this code in multiple variants, and then creates this virtual machine. And running a little bit out of time, so I'm going to show it briefly. So the system builds first a Docker image to compile the binaries. Yes, so use Debian bookworm, and inside of it, it installs the dependencies in Composer, and then it builds two versions of LLAMA.CPP, one for generic CPUs and one for GPUs with AVX2 extensions. That make a significant difference in speed, but sadly, because these are binary executables, if the CPU doesn't have AVX2, a binary for AVX2 just croaks and dies, saying illegal instruction. So the system actually builds the LLAMA.CPP and the SQL extension twice, one with generic build and the other with AVX2. These builds takes like about an hour. So they are fairly heavy builds. And then when these builds are done, it makes a final version of the image for which it, different from normal Docker images, it actually installed a user with a password and everything. And then in that image, it installs all the different dependencies and enables the Llama service and the PHP service. One of the reasons the project is also so small is because the virtual machine is so small is because it doesn't contain an Apache server or an Nginx server. It uses the interpreter, the PHP interpreter, to do the serving of the documents. After the Docker image has been created, everything, there is a lot of setup that needs to be done to take that image into an executable virtual machine. So for that, I wrote a shell script that creates an image on disk and install a bootloader in that image, and finally calls the VirtualBox convert program to obtain VMDK format. And finally, it makes the different manifest files, etc., to obtain an OVA that can be installed in. So all these scripts can be reused if you want to make a different virtual machine that use a different set of things. You can change the Docker file to build and install a different system that is not in PHP, for example. Okay, so now let's wrap up. Okay, so I do have the hope that people will also make money out of this, that independent software vendors will want to adapt this PHP code for customer-specific needs. So specific document segmentation and detagging, improve IR using faceted search, handling additional file formats, plugging in a more performant IR engine like Manticore, MariaDB Vector, etc. And that not all the Gen AI money find its way back to NVIDIA or Microsoft, which are right now the bigger players in the Gen AI world. You can currently, the current status of the system, the system does work. I mean, you launch it, it indexes documents, you can search. You cannot delete documents, that's a known bug. The hybrid embeddings plus keywords doesn't work yet. Keywords, the documents has to be very small, otherwise you will enter into chunk size problems. There is no upgrade functionality, and there is no external API. The external API is an enhancement that I really wanted to have for this release, but I just didn't get around. The other thing that the system is missing, while the PHP semantic search classes do support multilinguality, and that was something I spent quite a bit of time, given the fact that the contract was in French. So for that, I actually have to migrate sentence piece to run from PHP. Sentence piece is a very complex tokenizer that handles 100 different languages. So it handles tokens for Arabic script, it handles tokens for Chinese, Japanese, etc., which are very, very complicated. So that's already all packaged for PHP. using, and we have an embedding, the multilingually 5 small, that handles embeddings for English, Spanish, French, and those 100 languages. The current virtual machine does not have these requirements in place, but it will be straightforward. The main issue is I don't think the stable LLM supports those languages, but other people have been telling me that it might, so we need to do some testing on that. It might support it because Stable LLM comes from Stable AI, that is a French company, so maybe it does support multilingual. If you want to contribute to the project, this is the URL. If you want to just know more about it, that's the webpage. And my intention is also to have a list of vetted independent software vendors listed on GitHub on the webpage. So if you sign up, press pull request that shows that you have a non-trivial understanding of the project, I'll be happy to list other people in there. Other announcements, I'm the maintainer for the UIMA C++ system, and I just finished a Google Summer of Code. And I have created a LLAMA.CPP annotator for UIMA. So you can run an LLM for example, each sentence of a document, and that enables some interesting applications. And now to wrap up, so we can finish on time. To me, it's time to go back to the P in NLP, the natural language processing. I'm seeing a lot of people doing a lot of LLM work where they take the text and they don't really handle it very well. Seeing things like splitting sentences into periods, that doesn't work. I mean, you have acronyms that end on periods, like doctor dot, yeah? So it's kind of this LLM craze is making us forget that text is still an artifact that deserves some level of care and understanding. So to me, successful LLM deployments need a lot of programming and smarts that are outside the LLM part, yeah? And in that sense, the RAG Edge project allows new players that are versed in traditional programming join the field and contribute to that part, yes? The LLM here is really a black box, but then we can add all these other things to make useful systems easily in languages for which there is a lot of global mind share. And well, I've been answering questions throughout the talk, but if there is any more questions, I will be glad to take them. Otherwise, thank you very much, and thank you for your time.
Thank you, Pablo. I shared a bunch of the links in the chat, and we will have them also shared in the video description. We'll hang on for a couple of minutes if anybody in the audience has any questions to ask. I think we did have a lot of good questions along the way that were answered, so that's good.
All right, so if you have any later thoughts on stuff, feel free to contact me on formerly known as Twitter, or I'm also very active on Discord,
LinkedIn.
also, or LinkedIn. And you can also email me directly. My email is in my webpage, but I'll put it here. And
great, thank you. For everyone joining, we will have the recording up within 24 hours with all the resources. And thank you so much, Pablo.
And thanks for hosting me. Have a good day.
Bye.